We now invite Professor Salman Khan, Associate Professor of Computer Vision at MBZUAI in Abu Dhabi, to walk us through his research proposal and expected outcomes.
All right. Hello, everyone. Good afternoon. My name is Salman, and today I will be talking about this project, Climate Copilot, which is around developing an agentic pipeline for climate resilience in MENA region. So first of all, let me thank ADIA for this award. And beside me in this partnership, in this team, we have colleagues from UCSD, G42, Inception, and also strong in-kind support from Microsoft AI for Good Lab. Right, so let me begin. What is the challenge, right? If you look at these photographs for the northern Iraq Mosul area in April 2020 and April 22, we see there's this dam lake which has been shrinking quite drastically. And this leads to a loss of farming area, which is 2 times this area which we can observe in 2020, and if we compare just 1 year before, 2019, it amounts to roughly 4 times decrease in the farming area, and this area is as large as perhaps the total size of country of Austria. So this is a significant change, and we call this MENA twin crisis. So on one side, water resources have been depleting over time, and also on the other hand, due to climate change, rising temperatures, the crops are facing a lot of stress. And right now, there are a number of models, great contributions from the community in terms of hydrological models, crop models, climate and weather forecasting models, like some of the colleagues were presenting earlier today. And we think perhaps there is a layer which can be contributed by recent advances in AI, which we call the AI agentic layer, that can perhaps reason across these fragmented modalities and models which have been developing by companies and enterprises like Google, NVIDIA, Microsoft, and perhaps this can deliver more than what is possible with just these individual models. So here is sort of a high-level overview. At the bottom, if you see on the left, we think perhaps you need a more capable foundation model at the core of this agentic system. And this we call as the orchestrator or the central core. But this needs more than what is possible today with the weather and climate models. And I will come to that in a while when I talk about this in more detail. But in essence, you can imagine we can have satellite image sources, IoT sensors, in situ measurements coming in from the ground information, climatic models that provides us forecasts, and also a lot of historical data, the domain knowledge, the IPCC FAO reports, which can also feed into this multimodal foundation model. And then there are a number of downstream tasks which are possible, not just question answering, but also in terms of scenario simulations and providing recommendations for decision makers and also end users, laypersons like farmers. On the right, this is just sort of an example interface we expect to develop as part of this project, but the queries would be much more complex, right? So for example, what will be the groundwater deficit in Upper Egypt next spring under El Nino conditions, right? So the current models cannot answer these complex queries because perhaps you need to do a combination of multiple things. So you would need a forecast in terms of your climatic conditions. You would need to combine information from the crop models, and then looking back at the historical reasons, just like a human expert might do this analysis, can we do this automatically? So this is the main goal here. So on top, we have sort of two main components of this pipeline. The core hypothesis, as I mentioned earlier, is that perhaps by orchestrating a dialogue between these individual models and diverse data sources, we can achieve more than what is possible today with a single model. And this is the main core here. Can recent large language models perhaps act as an orchestrator in this process with the ability to understand this multimodal data and can do this agentic reasoning to utilize the relevant tools where necessary. So as I mentioned earlier, the first core gap we believe in the literature is having a really capable foundation models, but then making sure that the semantic information is intertwined with the graded data, the satellite measures for Earth observation, as well as the historical data which exists today. So once this foundation model is there, which can correlate the concepts appearing in language with the phenomena, the climatic phenomena, there would be an agentic layer that sits on top, but it can utilize not only this multimodal foundation model, but perhaps any machine learning or climatic model for simulations, for scenario assessments, as well as tools. And this will take in the complex queries, break it down into simpler steps with the knowledge that what tools are at its disposal, and then systematically, step-by-step manner, solving that particular task. And the goal is to have not only a response which is just providing a response to the input query, but also having all these steps, the explainable answers, which is something very important for traceability. Now, at the bottom, there are two main applications we are going to focus. The first one is on the water security, queries, around water resources, how they might change in response to certain events. That is the first key component. And then the second component, which is again linked with the first one, is on food security and how, crops might get affected due to specific climatic events. Of course, something like this would benefit from as much diverse data and as much high-quality data that we have. And we have four main pillars that are going to feed into this pipeline. We have tried extensively to make sure that we are leveraging all the global open data sets. However, this pipeline would also benefit from proprietary data sets which are available with local agencies or national level bodies. So the first sort of data pillar is satellite remote sensing. Here, sensors like GRACE, which look at the Earth gravity to estimate the underground water levels. Those will be very useful. Sentinel-2 can provide multispectral inputs ranging from 10 to 20 meter resolution. They are available on 5 daily basis. That is also going to be quite useful, together with Landsat, which provides the thermal band for land surface temperature estimation. MODIS, Terra, and Aqua sensors can provide us information about ET, which is how much water is going back from the soil and plants back into the environment. The second main pillar is going to be the GIDC stream flow. It will provide information about the water discharge. FAO vapor portal is quite useful. But as I mentioned earlier, we are also, this is part of the plan, how to go reach back to the national level authorities in getting further more detailed information about the well logs and well gauges in terms of measuring and estimating the groundwater. The third component is going to come from the graded climate data and projections. As we know, ERF5 provides, from last 40 to 50 years historical reanalysis data product, which combine observations with the previous simulations. MIRA2 can add in additional information about the moisture flux. Then we have long-term sort of climatic projection from CMI6. And Codex regional model would also be useful. This is something we are going to look more deeply as well if there's a possibility of actually downscaling for the regional forecasts. The last pillar, which is very important again, is to leverage all the existing reports, all the information, new operational information which is getting available, as well as the peer-reviewed literature, from archive, from journals, wherever it's under permissive license, to make sure that this core has a good grounded information about the climatic phenomena. So this is the data part, and then what we are going to work on in terms of the model. So we have previously developed one of the first and earliest foundational conversational models for Earth observation data. So here's an example on the right-hand side. We call it Earth Dial, short for Earth Dialogue. It was presented this year in CVPR, and the goal was to make sure that we have an LLM that can understand not only the RGB imagery, which is coming in from the satellite sources, but it can also understand multispectral data, with different resolutions, different time scales, and also multispectral and multitemporal data. So if you have, for example, 2 snapshots before and after, how an LLM can analyze that and summarize the changes which are happening in the satellite imagery. So this was one of the first works in collaboration with our colleagues at IBM. And recently, down below, if you see on the right-hand side, the Copernicus FM. Just last week, I was in Hawaii, Honolulu, where we were attending ICCV, and this was one of the best paper candidates. And again, here the authors show how you can expand in terms of the input modalities, going further from just the optical data, but from one sensor, but how you can have multiple data sources simultaneously present so that you can do more in terms of downstream applications. So the first part is again going to center on the multimodal foundation model, but here the main challenge for us would be to see how a recent weather forecasting model, for example, Stormer, Climax, ForecastNet, and from Huawei, there are Pangu Weather. From Google, there are other models as well. And in here, I've just listed one model because in terms of the variables that it is considering, it is one of the most extensive ones, the Aurora model, how we can plug it in with a textual backbone, a backbone which can understand the natural language expressions and can relate it with the climatic phenomena. So this is the first goal, which will be around the multimodal foundational side. On top of that, as I mentioned, the agentic AI pipeline is going to take in complex queries and decompose it into step-by-step process. And here's again an example, some recent work we have done for the geospatial imagery on the right-hand side. So we have before and after images of a disaster-hit area, and then we ask a question, how many shipments might be required to do relief effort in here, and then the model will go back, try to have these 3-step process in terms of thoughts, actions, and observations about using the tools which are available. And the main question for us in this agentic AI pipeline is to see how we can replicate something like this for the climatic problems. The third thing on top of this, of course, we have to teach the AI model how a human expert follows this pipeline, right? If they are looking at all these observations, the historical data, what kind of workflow they follow, and what is the pipeline they would try to replicate. And in this case, we would need a form of reinforcement learning with experts to see how this decomposition of complex problems can be improved by the model. And again, in this direction, we have been doing some parallel works on the geospatial LLMs, which are looking at satellite data. So on the right-hand side, I have put in this example where we are learning a policy model. It is just a large language model, which is fine-tuned with the incentive to actually interleave some thinking tokens in its output response. So the query here is, can you identify the 2 white passenger ships? And this policy model, the LLM, will have an incentive, a higher reward, if it can interleave these thinking tokens before spitting out the final response. And down below in the middle, if you can see, a model, a sample output where it says, okay, perhaps I need to focus on the key visual cues which relate to the passenger ships, and because there are 2 elongated figures present at X and Y locations, so perhaps these are the ships. So this is again without a human expert-based reward model. However, for our problem here, there would be an opportunity to explore both human feedback in this pipeline as well as verifiable rewards which can be generated automatically as well. Again, of course, it is possible to develop such kind of an agentic pipeline. There are many, really important items one should be aware of. These models today can hallucinate. They can, just get stuck in one of the steps. They could take a long time, which is unnecessary. And these are some of the problems, the agentic pipelines which have been developed today. They're also facing similar challenges. So the main goal in this project for us will be to make sure that we are generating responses which are grounded in reality. They are not hallucinations, and how we can track all this data provenance. So what data we are basing our analysis on. When we generate an outcome, an analysis, how much reliable is this? So uncertainty quantification is really important here. And then the tool chain audit, just like the previous example I showed, what tools are used in what sequence? Is this something plausible in this context? And again, for this, benchmarks are really important. So on the right-hand side, I put in this example. It is from natural image domain, any multimodal inputs which are available through an agentic pipeline, and the agent would break it down into specific steps. And this work recently received the second prize for reasoning and planning under the Agent X competition at Berkeley. So we are learning from these experiences and seeing how they could be translated to the climate problems. So in a nutshell, what is the main gap we hope to bridge here? If you look at the current state of the art, there are many excellent examples which were explained today by Stan and other colleagues on weather foundation models. So we see really good examples now which are performing better than the numerical models. However, they are generally, they are not equipped to process the textual inputs or the semantic input or the natural language input. They are, they will take in a slice of images and generate a forward-looking time horizon specific generation of those variables. Again, we also have several Earth observation foundation models which can generally accept the inputs which are coming in the form of images or multiple bands of this imagery. They can also take in sometimes the language input. However, they cannot understand the climatic phenomena. And similarly for general LLMs, if we talk about the recent releases, models like Claude, GPT-4, Gemini, and so on, they cannot interpret and understand the climatic phenomena. So the goal here is to see how we can bridge this gap to have more than what is available with single models, the siloed models available in the climate tasks. So the potential impact of what we're hoping is that something like this would be very useful for water authorities in terms of planning, for example, reservoir releases for farmers and agri-tech if they want to receive earlier warnings about heat and water stress. Policymakers which can look at the step-by-step process, how the AI agent is solving or attacking that problem, and what can we learn new from that, which perhaps the experts, human experts, can verify and validate in terms of any implementation. And finally, towards the scientific community, we are expecting to develop new benchmarks, data sets which are aligned, and also the foundation models that can interleave the climatic inputs as well as the textual information which is available in text. So with this, I would like to end here, and if you have any questions, I'm most happy to take them.
Hi, thank you for an interesting presentation. In terms of, you said at some point where you are checking how the output from the LLM is getting the weather data. Did you try something like mechanical interpretability, trying to go to search how the LLM is creating the features in terms of your data? This can be a way, because that part of mechanistic interpretability goes inside of LLM and can detect, at least in the vision model, as well in the LLM recently. I know there is a research with the Berkeley's and Anthropic, discovering during the neural network in the LLM, you can discover which part of the LLM is getting that feature from your weather data. Did you think about this, or how do you check the reliability and interpretability of the LLM?
Right.
Thank you.
So in this pipeline, when we are talking about, using different tools, what we can do here is, because this agent is going to take some actions. These actions, if you're talking about embodied agent, they would be in the real physical space. If you're talking about digital agents like the one, a climate copilot, they would be taking certain actions in the digital space. So they would be, running, for example, a simulation model, looking back, at a text document, a report, for example, from FAO or IPCC, and then, generating, for example, sort of some context from there. So when we talk about the data provenance or checking the reliability of outputs, because these are all tracks of the actions which are completed by the agent, in this case, which would be an LLM, then we can track it and make sure that it is on the right track.
Hi, hello, my name's Rukeya. I'm a digital infrastructure consultant. So I have a question. Very interesting speech, by the way. Thank you for the presentation. When you mentioned sovereignty and data sovereignty, that's my area of expertise in relation to the design of data centers. So in order to protect this data, and I understand it's a byproduct and it's an application, however, in relation to the sovereignty to secure the data in which this area, specific area of the climate is monetized, what do you have in place in relation to keeping it secure? So, for example, lately we have the embargo of quantum. That's one of my personal favorite subjects. And in relation to, it's been predicted now in 10 years' time, quantum is going to make that leap and that interconnect. And from the conversation I've been having, is AI is going to be the software, quantum is going to be the hardware. So in relation to the sovereignty and the data, are you putting it in relation to a specific location, allocated a sovereign data center for this application? And then my second question is, have you got things implemented in place, such as quantum key distribution and things like that? Because when you're looking at the climate, it can sometimes configure and overlap to be geopolitical. And so what things have you got in place to secure the data, secure your infrastructure? So this is used as a tool, and which it is, it's a tool. Of course, the human has to steer the ship, not the ship steer the human. So what have you got in place? Thank you very much.
Thank you very much for your elaborate question. So in this project, this is something which is out of the scope. We are not specifically looking at making sure that the systems are secure. As you know, with AI agents, security is a big problem. Even if you are today using ChatGPT agent, they will put in this disclaimer that please lock out of your account. There are data poisoning attacks. There are all sorts of different attacks which can steal the information, very critical and very useful information from the users. So that is an ongoing challenge. In here, there are two aspects. So first is we are mostly working with the open data sets, open reports, which are in public knowledge already, the literature which is there, all the climatic data sets, Earth observation data sets, which are in open domain. I put down the examples. So as far as those are concerned, we believe that that's not a major challenge. However, user queries, when they're interacting with the system, there of course need to be secure, and there are, sort of as in this project, we'll be generally leveraging all the layers of security which are already there in the cloud service providers. We won't be innovating over there. However, as far as agents are concerned, this is a big problem, and I totally agree that this is something which needs to be looked at very closely.
A quick question. Have you worked with Destination Earth on any of this, or are you thinking of? It would just open access to a new quality of climate information, and I didn't know what your experiences were working with them.
Thank you, Professor Stevens. So we haven't looked at that, but thank you for the pointer. We will definitely consider that as well.